Hi everyone, I am a representative of the Group 6 and we will talk about topic 7 which is normalization. And here is our group member. First we have FARAH WAHIDAH BINTI BAKAR, HAFIZAH binti IZMADY, ADRIANA binti FAIZAL, and me, SITI ZULAIKHA binti MOHAMAD. In this topic, we will teach how to determine and evaluate the result of an accurate logical model that contains the minimum number of anomalies. The technique referred to is normalization. Normalization is a significant academic contribution to the design of relational databases. In this topic, we will explain the concept of anomalies in a relationship and how the anomalous elements can be reduced through normalization processes.
So, for purpose of normalization is a formal process used in database design to systematically structure data. It ensures that every relationship in a table is based on primary or candidate keys and functional dependencies. The goal is to ensure data accuracy and minimize anomalies like duplication, update, or deletion issue. How to determine and evaluate the logical data model? First, use a bottom-up approach to design the database. Next, ensure each table, which is relation, has clear attributes that satisfy functional dependencies. Next, verify the relationship schema is free from anomalies like duplication or update conflict. The last one is test the model for accuracy by reviewing primary and candidate keys. Next, I will explain about types of updating anomalies. Number 1 is insertion anomaly. Insertion anomaly is occur when new data cannot be added without including unrelated or unnecessary data. Example, adding a new student require entering course detail even though they have not registered for a course yet. Number 2 is deletion anomaly. Deletion anomaly is occur when deleting certain data leads to the loss of other important information. For example, deleting a student record also remove course details that are still relevant. And the last one is modification. Modification anomaly is occur when updating data require changes in multiple places, causing inconsistencies. For example, changing a lecturer's phone number require updating it in all records where it appears.
Normalization process. Normalization minimizes anomalies found in each relation. Tables with excess data and high anomalies are divided into several tables. Normalization process has 1NF, 2NF, 3NF, and BCNF. The goals ensure data is accurate and consistent, reduce redundancy, and avoid anomalies, so that benefit better database design, easier to update and maintain, prevents data inconsistencies. What is 1NF, 2NF, and 3NF? 1NF, first normal form. All values in the table are atomic. Each record row is unique, has a primary key. There are no repeating group or arrays. Second normal form. This is in 1NF. There are no partial dependency. A non-prime attribute, a column that is not part of the primary key, must depend on the whole primary key and not just a part of it. Third normal form. It is in 2NF. There are no transitive dependencies. A non-prime attribute cannot depend on another non-prime attribute. Every non-prime attribute must depend only on the primary key.
Okay, let's understand with the example. First, 1NF, first normal form. Rules for 1NF, each cell must have atomic, no repeating groups or arrays in a column, and every row must be unique. Step 1, add a unique identifier if rows are not unique, and second, ensure all attributes have atomic values.
In this case, the given table satisfies automaticity but needs rows to be uniquely identified. We can achieve this by creating a composite primary key using employee ID, and job code. Second is 2NF, second normal form. Rules for 2NF is satisfy 1NF, remove partial dependencies, non-prime attributes must depend on the entire composite primary key, not just part of it. Step 1, the composite primary key is employee ID and job code. Second, identify partial dependencies. Attributes like name, state code, and home state depend only on employee ID, not the entire composite key. Decompose the table, create separate tables for employee details and job details. And third, 3NF, third normal form. Rules for 3NF is satisfy 2NF and remove transitive dependencies. Non-prime attributes must depend only on the primary key. Step 1, identify transitive dependency. For example, state code determines home state in the employee table, and create a separate table for states. In conclusion, normalization in database design is a process of organizing data to minimize redundancy and ensure data integrity. It involves dividing large tables into smaller related tables and defining relationships between them to reduce anomalies during data operations. The process improves efficiency, consistency, and scalability by ensuring each piece of data is stored in only one place. It typically follows a series of steps called normal forms 1NF, 2NF, and 3NF, each addressing specific data issues. Ultimately, normalization enhances database performance and make it easier to maintain